Hey, what's up, guys? Today we're looking at longest repeating character replacement. So, pretty much you're given a string S and you can only replace up to K characters to be any other character, and you want to figure out the longest substring that consists of just one character. So here in the example, we have K equals 2. We can replace two characters in this array or in this string to be any other character, and we want to figure out what's the longest substring we can make that's just one character. So we can either replace these two B's to be A's, or we can replace these two A's to be B's, and we could either get A or B. Either way, these would give us two substrings with a length of 4 that also only contain one character each. So there's no duplicate characters. So this is kind of a weird question, right? It's kind of tricky even to think about in your head just because it's crazy sounding, it's weird sounding. But what we want to do is the fact that they tell us longest substring should instantly, red flags blare, and it should be a giveaway that this is sliding window technique or this is solvable using sliding window technique. And the keywords longest substring just kind of make it clear that this is a sliding window technique, which means that we're going to get an array, and we'll consider this string just to be an array of characters. But with this array, we're going to keep a window, that takes a look at each element. So this will be the first time, and then the second time we'll update it, and then we'll update it, and we'll keep updating it until our window is no longer valid. And once our window is no longer valid, or it doesn't meet a certain condition, then we're going to, instead of incrementing the end of the window, we're going to increment the start of the window. So now we'll just take a look at this and we'll see, is this window valid? If not, then, well, is this window valid? And if not, then, well, is this window valid? So on and so forth. So for the sliding window technique, you're going to increment the end of the window until you hit an invalid window. And when you hit that invalid window, what you do after that is you start incrementing the start of the window. So that's just a very brief, very rough rundown of how sliding window works if you haven't seen that already. Now let's take a look at how we can implement it for this problem. So if you have this array of characters, then there's a few things that you need to keep track of. First, you need to keep track of the start of the window. You should be keeping track of the end of the window. You should be keeping track of a max length variable, which is just going to be our result that, this is just going to be the max length that updates every time we hit a new max length. And you should also this is kind of the key to the question, you should be keeping a hash map of all the characters. So as you iterate through and as you move your window along, your hash map should contain all the elements and their counts, right? So the first time through, your hash map should then put 1 for A, and then once it hits B, once it hits this second index, then, or this first index, I guess, then it should add B1. And then this next time through, it should add A2. And then this final time through, it should add B2. So this hash map should be updating every time you iterate through this array. Now, there's some condition then that should make this window false, right? So what could possibly make this window false? At what point do we know that, okay, we've hit enough characters such that if we replaced up to K equals 2, if we replaced up to 2 characters, even if we did that, we still wouldn't have one character, right? Then let's imagine that this hash map was longer and it wasn't just AB. What if it was, AB, C, 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 okay? Then at this point, you have AB, which is all fine and good. It's 2, 2. If you replace one of these, then if you replace one of these to be this one, then you get 2, 2, 2, which is, or sorry, you get 4, 0, which is fine. You just have 4 of one character, which is good, and that's what you want. But now, if you include this C variable, or if you include this C, then even if you just go 1C, then if you have C1, then at this point, we've hit kind of an invalid sequence, right? This window is no longer valid because if you have 2 A's, 2 B's, and 1 C, how could you possibly switch around 2 elements so that you would be able to get, a substring of just one character? Now, the way you think about this, like, what are we thinking when we are trying to replace 2 elements, right? Well, what element are we naturally gravitating to? I feel like it's kind of obvious that in our solution, we wouldn't be trying to turn B's and A's into C's, right? Because there's more of B's and A's. So what we'd be trying to do is we'd be trying to turn C's into B's or A's and A's into B's or vice versa. But either way, we naturally gravitate to having our original character, the character that we're going to convert all our other characters to be the character with the most count, with the most counts thus far. So that means that we have to keep track of another local variable that's most common, and this should be keeping track of the most common count that we've seen thus far. And the reason we know that this is no longer valid is because the length of this hash map, or I guess yeah, the length of this sequence, this window so far, has now the length minus the most common has surpassed k, right? Once it hits this I guess this condition where the length minus most common is greater than k, then it's invalid, and at that point we can update the max to be whatever the length was right before we hit that condition, right? So length minus one, I guess. So if that doesn't make sense, then we'll take a look at the code and hopefully it'll kind of come together there. But for now, let's look at the complexity of the solution. So time complexity is going to be linear. That's a strength of sliding window, is that it's always linear time because you're only iterating through it once, right? You're going through to the very end of the array one time, and then maybe you would do another iteration just of length O of n. So like worst case scenario, this would be O of 2n, but that just simplifies down to O of n. So this is linear time, which is pretty good. And then our space complexity is just going to be, the only space that we're adding is this hash map that contains a max of n characters. So this is going to be O of n as well. So linear time, linear space. Okay, now let's take a look at the code. All right, so the very first thing we'll do is we'll set all variables we'll need. So we'll let the start of the window be equal to 0, because obviously we're just going to start the window at the very beginning of the string. And then we're going to let a max length variable equal 0. This is going to be what we'll return. We'll let a most common variable equal to 0. This is going to be keeping track of the most common element that we've seen so far. We're also going to let a hash equal an empty array, or an empty object, which we will then convert into our hash map. And yeah, that's it. That's all we need. So now at this point, we can traverse through the string. We can, start incrementing our window. So instead of using I, we'll use a window n variable, and we will increment it through all of s. Now, the very first thing we want to do is we want to start creating this hash, right? We want to see if the hash, if we've hit a character that we've never seen before, then we'll set that equal to 0. But we want this to be equal to 1, right? So after this, we will increment this at whatever, should be equal to 0, and then this gets incremented. Now what this will do is that if we've never seen a variable before, or if we've never seen an element before, then we'll set it to 0 and then we'll increment it. So then it'll be set to 1. But if we have seen it before, then we skip that and just increment it anyway. So this is just kind of a neat little trick, a nice little way to make hash maps. Okay. Oops. Okay, and then once we have that, then at this point we can update our most common. So this is gonna come right after this, right after we just updated our very last element in the hash. Now we want to see now that we've added this new element, is our most common going to be updated with whatever we just added? If that's the case, then we update it. So now our most common works and our hash works, and we can actually figure out that our temp length, or I guess the length of the string, is going to be the difference between the end of the window and the start of the window plus 1, and that's just kind of how it works. So we'll say if window end minus window start plus 1 is if the temp length minus the most common thus far, and this is going to give us the amount of characters that we have to replace for it to be a valid sequence. If this is greater than k, in other words, this is our condition where the window is no longer valid. And if once we hit this, then we can update. We'll just slide the window forward. So we'll decrement whatever the hash was at the window start, and we can also increment window start. And then after this, we can update our max length variable, right? So whether this happens or not, it doesn't matter. We're going to be updating our max length variable to be the max between whatever we currently had in max length and also like the temp length, right? And keep in mind that the temp length for the incorrect condition has been updated, right? We incremented window start to, be 1 higher. So this is going to work both for the condition where, we haven't hit incorrect statement and a condition where the window is incorrect. So either way, this will work. And that's it. That's all of our code. We can just return max length, and this should be the answer. Let's see. Okay, sorry, forgot to increment this. Now this should be the answer. Yeah, and yep, that works.